Welcome back to the class on electrical vehicles and hybrid electrical vehicles. In this lecture, we are going to discuss about the battery requirement for the EVs and HEVs. The energy storage of the battery is required for the desired drive range. The input power capability of the battery enough to give the good acceleration and a good regenerative braking for achieving the high efficiency and to accept fast charge for the vehicle convenience. Nothing but the input power of a battery should enough to give the good acceleration as well as a regenerative braking of a electric vehicle. The life of the battery almost all equal to the IC engine based vehicles. The durability against the environmental demand so that EV can work in a harsh environmental where conventional vehicle should normally work. There is good tolerance for the battery for the safe under extreme conditions. Nothing but overcharging, internal short circuit. 5 requirements of a battery when you're going to use the batteries in a electric vehicle. Nearly 5 batteries are used repeatedly in electrical vehicles. One is lead acid battery. Already we have studied about the lead acid battery. Positive electrode is lead oxide and negative electrode is lead aqueous sulfuric acid. This is the chemical reaction what is occurs in a lead acid battery. The second one is the nickel metal hydride battery. Nickel oxide is a positive electrode, negative electrode is a metal hydride, and a potassium hydroxide aqua is an electrolyte. This is the chemical reaction which is occurs at a positive electrode as well as a negative electrode. Lithium ion battery. Cobalt oxide as a positive electrode, graphite or coke are the negative electrode, organic electrolyte. This is the chemical reaction which is occurs at a positive electrode as well as negative electrode. Here we can find X where the X value will be lies between the 0 to the 1. Zinc air battery. Oxygen is a positive electrode, metallic zinc is a negative electrode, potassium hydroxide is the electrolyte. Fifth one is the sodium metal chloride battery. Another name for the sodium metal chloride battery is the zebra battery. Nickel chloride is a positive electrode, sodium is a negative electrode. Beta alumina, nothing but a sodium aluminum oxide with a complex mixture we are using as electrolyte. This is a chemical reaction which is occurs in a zebra battery. The upper arrow is representing the charging, the lower arrow is representing the discharging. Now we are going to see one by one. Already we have seen the lead acid battery operation. The lead acid battery is the oldest battery. It is cheap and simple also. It has reached the limits of a specific energy. For this reason, it never be option for the electric vehicle. Besides, its life cycle of the battery also will be low. Battery pack will need it to be replaced every 2 to 3 years. There is some experience with lead acid battery. If the lead acid battery is charged at high currents, cycle life of the battery will be decreases. The use of lead acid battery will not be declined in a near future because it is less expensive than the other energy storage devices. In general, lead acid battery presents a cycle life of around 700, the specific energy around 35 watts per kg and specific power around 150 watts per kg. Nickel metal hydride battery. Nickel metal hydride battery is well suited for the EVs because its performance is very good in terms of a specific energy and a cycle life. The nickel metal hydride battery composed of non-toxic recyclable material. It is environmental friendly. The life cycle of the nickel metal hydride battery around 1500, the specific energy around 70 watts per kg, the specific power around 200 watts per kg. One of the main drawback of this battery is it is costly when compared to the lead acid battery. Around 10 times it is more than the lead acid battery. Lithium ion battery. The specific energy of a lithium ion battery is very high. It has a high level of intrinsic safety can be reached in the cell level itself. Apart from that, the system level also we are adding some of the safeties to the lithium ion battery. Lithium ion battery can be charged at very high currents, nearly 5 times charging current related to the normal capacity with a very good life cycle. This shows that the battery side fast charging is no longer a problem. The actual battery capacity of the electric vehicles around 50 kilowatt hours to the 20 kilowatt hour, resulting a high charging power of 60 kilowatt. This much of power is not available in a household purposes where 220 volts by 16 amperes nearly 3.3 kilowatt is available. So we can't charge the lithium battery in a household purpose. So to charge this type of batteries, it requires a charging station separately. So the infrastructure of the charging station has to be implemented in a future. Zebra battery. Sodium nickel chloride battery are nothing but a zebra battery. It is operating at a high temperature inside nearly 270 degrees but cold outside. Despite this drawback, this battery is a good choice for the electric vehicle because safe, low cost, can endure a 1500 cycles without significant degradation. This type of battery also we can discharge nearly 100% without losing the life cycle of the battery. The specific energy is comparable to the lithium-ion battery. Another interesting point of this battery is keeping it cooled. It can remain at a unlimited time without damage. The specific power of the Zebra battery is low when compared to the other batteries. Zinc air battery. In a zinc air battery, the main disadvantage is the electric fuel. Zinc air battery has a very poor cycle life. For this reason, is not recharged electrically. It is charged through a series of mechanical and electrochemical steps which requires a special infrastructure. Electric fuel zinc air battery consisting a battery pack with removable zinc anode cassettes, an automated battery exchange unit located at a specific place or at a refilling station. Suppose once the battery is discharged, the anode cassette has to replace. The refilling mechanism is used to replace the depleted anode cassette with a recycled and recharged cassettes. In a regeneration process, the discharged zinc oxide is dissolved in the electrolyte process that forms a charged zinc particle that are then made into new anode cassette. As these batteries are very poor specific power and also difficult to charge this type of batteries, EV with this battery cannot be used for the regenerative braking. Also, the cost becomes a high because it has to consider all the processing charging using a special electrochemical plate to recover the zinc anodes. Advantage of this battery are the long distance it can cover with a one charge and the rapid charging time. Nothing but it does not require that much of time to charge it. Here there is no point of charging, just you have to replace the anode cassettes. Comparison of the batteries in terms of four parameters which are very essential when you are going to use the batteries before going to use in a electrical vehicle. One is specific energy. The specific energy is related to the how much distance is traveled by the vehicle during the one charge of the battery. Specific power will be deciding how much acceleration the vehicle can go. Next, cycle life and cost of the battery also. These are the different batteries what we have discussed. These are the specific energy of the different batteries. This is the specific power of the different batteries. This is the cycle life. But here if you see the zinc oxide battery, the cycle life is depending upon the replacement of anode. This is the cost per the kilowatt hour of a battery in US dollars. This is in a Indian rupees. Thank you very much. If you have any doubt, you can ask me directly or you can ask in the comment box of my YouTube channel so that I am always welcome to answer all your questions.